Imagine trying to do math without the number zero, no placeholder to tell thousands apart from tens, no way to express nothing, no negative numbers, no calculus, no computers. Sounds impossible, right? Yet, for most of human history, the greatest civilizations on Earth, the Romans, the Greeks, the Egyptians, functioned without it. Zero wasn't just missing, it was unthinkable. Today, we're exploring how a simple circle became the most powerful concept in human thought, reshaping mathematics, enabling modern science, and building the financial world as we know it. This is the story of zero. Let's travel back to ancient Rome around 100 CE. You're a merchant trying to record your inventory. You have 305 amphorae of olive oil. In Roman numerals, that's 305. But wait, what if you had 3005 amphorae? Still 305? You see the problem. Without zero as a placeholder, large numbers become ambiguous. You'd need entirely new symbols or confusing context to tell them apart. Now imagine you're a Greek mathematician trying to solve an equation. You arrive at the answer, nothing, no solution. The Greeks called this paradox. They literally couldn't write it down to them. Numbers represented quantities of things, and you can't have a quantity of nothing. That's not a number. That's an absence, a void, even something dangerous. The Romans felt the same way. Their system worked fine for counting and record-keeping, but try multiplying 94 by 67. I'll wait. You can't. Not easily. Roman numerals were never designed for calculation, only for recording results someone had already figured out using counting boards. But here's what's fascinating. The absence of zero wasn't just a mathematical inconvenience, it was a philosophical barrier. How could nothing be something? How could emptiness have value? These weren't just math questions, they challenged how people understood reality itself. And yet, on the other side of the world, one culture was about to crack this cosmic puzzle. Around the 5th century CE in India, mathematicians were exploring ideas that would change everything. Indian scholars like Brahmagupta weren't just counting, they were treating numbers as abstract concepts. They used a Sanskrit word, shunya, meaning void or empty, and they gave it a symbol, a small circle or dot. This wasn't just a placeholder, it was a number. You could add it, subtract it, multiply by it. Brahmagupta wrote rules for it. The sum of 0 and a positive number is positive. The sum of 0 and 0 is 0. This might sound obvious to us now, but think about how radical this was. They were saying emptiness has properties. Nothing can be manipulated. The void follows rules. But the real genius? Zero unlocked positional notation. Look at our number 305. That zero tells us there are no tens. Without it, we'd be as confused as those Roman merchants. With it, we can express any number, no matter how large, using just 10 symbols, 0 through 9. This system, which we call the Hindu-Arabic numeral system, made calculation exponentially easier. By the 9th century, the Persian mathematician Al-Khwarizmi was spreading these ideas across the Islamic world. His books translated Indian mathematical concepts into Arabic, reaching scholars from Baghdad to Spain. In fact, the word algorithm comes from a Latinization of his name. But when zero reached Europe in the 13th century through translations by scholars like Fibonacci, it faced resistance. The church was suspicious. Some cities banned its use in account books because it was easy to forge, turn a 0 into a 6 or 9. Merchants used it secretly to gain competitive advantages in calculation. Eventually, zero's utility won. By the Renaissance, it was everywhere, and mathematicians began discovering something extraordinary. Zero was a gateway to even stranger ideas. Once zero was accepted, mathematics exploded with new possibilities. First came negative numbers. If zero is the boundary between positive and nothing, what's on the other side? Debts, temperatures below freezing, positions below sea level, suddenly these could all be expressed mathematically. The number line now stretched infinitely in both directions, with zero at the center. Then came calculus. In the 17th century, Newton and Leibniz developed methods to understand change in motion. At its heart, calculus asks, what happens when you divide by numbers approaching zero? What's the instantaneous rate of change at a single point in time? These questions only make sense in a world where zero exists as a mathematical object. This unlocked physics, gravity, acceleration, the orbits of planets, all described using equations that dance around zero, approaching it, dividing by infinitesimal amounts near it, but never quite touching it. Without zero, we don't have calculus. Without calculus, we don't have modern physics, engineering, or space travel. Fast forward to the 20th century, computers. Every piece of digital technology you use runs on binary code, ones and zeros, on or off, charge or no charge. The entire digital revolution is built on zero's shoulders. Your smartphone, the internet, artificial intelligence, all encoded in patterns of something and nothing. But perhaps zero's most profound impact is in finance. Double-entry bookkeeping, invented in medieval Italy, relies on accounts balancing to zero. Assets minus liabilities equals zero in a perfect ledger. This system enabled modern capitalism, allowing businesses to scale and investors to trust their books. And then there's compound interest and present value calculations, financial concepts that require logarithms and exponential functions, all of which are impossible without zero as a foundation. In 2008, when we talked about zero interest rates or accounts being zeroed out, we were using a concept that ancient Romans literally couldn't imagine to describe the collapse and rescue of the global financial system. Here's what makes zero so extraordinary. It's not just a number, it's a philosophical revolution wrapped in mathematical notation. Zero forced humanity to accept that nothing is something, that emptiness has structure, that the absence of quantity is itself a quantity worth naming, worth thinking about, worth calculating with. Every time you check your bank balance, use GPS, or simply write the year 2025, you're using a gift from Indian mathematicians who dared to believe that nothing mattered. The ancient Greeks feared the void. They called it the apeiron, the boundless, chaotic nothingness that threatened order. But zero didn't bring chaos. It brought clarity, power, and infinite possibility. From its mystical origins in Indian philosophy to its contested arrival in Europe, from enabling calculus to powering computers, zero has been the quiet constant behind almost every scientific and technological revolution of the past 1,000 years. And the next time you see that simple circle, remember, you're looking at one of humanity's most profound ideas, the number that exists precisely because it represents nothing. Sometimes the most powerful ideas are the ones that seem the simplest, and sometimes nothing changes everything. Thanks for watching this first episode of Ideas That Change the World. If this story made you see numbers differently, hit that subscribe button, because we're just getting started. Next time, we'll explore another concept that transformed human civilization. What idea should we cover next? Drop your suggestions in the comments below. Until then, remember, even nothing is something.